Now, we've seen that scientific notation is very convenient because it'll let us write very large numbers and very small numbers in a very concise, compact way. We don't have to count a whole lot of zeros. But there is another advantage that scientific notation has, and that is it makes it very easy for you to specify how many significant figures you've got in a measurement. Now, to see why that's better than the way we have been doing it, let's look at a number. Suppose I have 58,000 meters, and I want to show how many significant digits I've got. Well, if I use the rules for significant digits, I'd think like this. There's some trailing zeros there with no decimal point. So that means that those aren't significant, and I've got two significant figures. Now, that's right. But really what I should say is that there's at least two significant figures there. That's what I can really tell. Because I don't really know, do I, whether this person measured out to the nearest 100 meters. Was that his estimated digit? I'm assuming it was the 8 that he estimated. But it could have been the 0. It just happened to be a 0. Or he could have estimated it to the nearest 10 meters. Or the nearest 1 meter. So I don't really know from looking at this if that's happened. All I can tell for sure is that there's at least two significant figures, because that's kind of the worst case for where the estimated digit is going to be. Now, I can do better than that if I turn this into scientific notation. If I turn this into scientific notation, all I got to do is bump the decimal point over. 1, 2, 3, 4 places. So that's going to be equal to 5.8 times 10 to the 4 meters. Now, I am showing unambiguously that I have got two figures there. Now, what if I wanted to show, though, that that was where my estimated digit was, in the hundreds place? I could write it like this. Now I am showing that there are three significant figures there. What if I wanted to show that that's where my estimated digit was, that I knew this to give or take 10 meters? Four significant figures. And you can see how it goes. If I had measured this to the nearest meter, I could write so the person who's measured this can show how many significant figures the reader should know that they've measured it out to using scientific notation. I would say anytime you've got a measurement with trailing zeros and no decimal point, and you've made the measurement, write it down instead in scientific notation so that whoever is reading this can see how many significant digits you've got without any ambiguity. Now, another thing that scientific notation can help out a little bit with is understanding why, when we write a number like this out, it has three significant digits. By the rules, I'd say, well, there's three leading zeros. They're never significant. And there's one trailing zero, but it is significant because I see a decimal point. So I'd apply those rules and I'd say, well, there's three significant digits there. But you can also see that another way besides the rules. If you turn a number that's less than 1 into scientific notation, the zeros that aren't significant will disappear. So let's do that. Let's write this in scientific notation. This is going to be bumped over 1, 2, 3 places. You're bumping the decimal point over so it is just to the right of the first non-zero digit, just like we did up here. That's how we knew to bump it over to just next to the 5, just to the right of the first non-zero digit. So you've got 2.70 times 10 to the minus 3. There's a negative exponent because we bumped this way. There's a negative exponent because it's a number less than 1. You can think of it either way. Now, those zeros disappeared when I did that, and they weren't significant. They were only showing you the magnitude of the number. And now the magnitude of the number, the size of the number, is it kind of encoded in the power of 10 that we've got here. This kind of says in English 2.70 thousandths, because 10 to the minus 3 is a thousandth. So that's another way that you can look at why this number has 3 significant digits.